Yes, welcome to Maths with EJD. I'm still solving a structured problem like I've been doing in recent times. And today we have a three-part question. Looks like all theory, so to speak. So what is statistics? Differentiate between descriptive and differential statistics. I mean, we've answered this kind of question a couple of times, but I think it's okay. B, differentiate with appropriate examples between parametric and non-parametric tests. And C, with the aid of an appropriate diagram, highlight data and its types. Let's go then. First of all, we need to talk about what statistics is. Okay. Um, we know that statistics is a branch of mathematics, if I can say so, the branch of mathematics that with deals with the collection, analysis, interpretation, presentation, and organization of data. Well, I think it can even be better. It should be something like collection, processing, analysis, interpretation, organization, and presentation of data. You can arrange it better, right? But let's have it this way right now. An organization of data. Okay. It provides tools. It provides tools and techniques for understanding patterns and drawing conclusions from data. It is used, it is used in fields such as science, business, economics, and social sciences to make informed decisions. Okay, now let's talk about the second part of the first question. Differentiate between descriptive and inferential statistics. So let's say this. Um, to differentiate, to differentiate between different descriptive and inferential statistics. Okay. First, let's have descriptive statistics. Descriptive statistics. Okay. Uh, this involves this involves summarizing and organizing data to describe organizing data to describe the characteristics of a data set, the characteristics of a data set. It uses measures such as mean, median, mode, standard deviation, and graphical representations like histograms, bar charts, and pie charts to present data in a way that makes it easier to understand. An example, for instance, would be something like calculating the average score, calculating the average score of a class in a mathematics exam. Okay, now let's talk about inferential statistics. Inferential statistics as the second type of statistics. Now this involves making predictions or inferences about a population based on a sample of data drawn from that population. So you take a sample from a population to make predictions about the population itself, drawn from that population. It uses techniques. Such as hypothesis testing, hypothesis testing, confidence intervals, and regression analysis to draw conclusions beyond the immediate data. Okay, an example of that, would be using a sample of voters' opinions to predict the outcome of an upcoming election. Okay, so that takes care of the first part of the question. For the second part, we need to differentiate with appropriate examples between parametric and non-parametric tests. So B, to differentiate between parametric and non-parametric tests, so let's start first with parametric tests. So these tests assume that the data follows a specific distribution, a specific distribution. So for you to use parametric test on any data set, it should be sure it follows a specific distribution, and that is usually a normal distribution. And that the underlying parameters such as mean and variance of the population are known or can be estimated from the data. Okay, let me not be miserly with that. Or can be estimated from the data. They require data, that is parametric tests require data to be on an interval or ratio scale. On an interval or ratio scale. So I mean that's this kind of pointers would show you when to use parametric tests. So maybe one thing you can check first of all is what kind of scale. If it is ordinal scale or nominal scale, then you know you can't use parametric test. If it is interval and ratio scale, one point checked. Another thing is, does it actually have is it normally distributed? If that's fine, then you can go, then you check for the third point, which is, do you know the mean and the variance of the population, or can you at least estimate it? So if you can check those 3 points, then you're good to go. So let's talk about some examples of parametric tests. So we have the t-test. We have t-test. I've treated all of this in the statistics playlist, which you can check. So for t-test now, t-test compares the means, of two groups to see if they are significantly different from each other. So there's also ANOVA. There are other tests, right? There's Z test and all that. I'm here to, in fact, ANOVA is the next topic I was supposed to take before before now. But it's okay. I mean, very soon that should come up. So analysis of variance is also another type of test, which is an extension of things like t-test or z-test, because now it takes care of it compares means it compares the means of three or more groups. So if you have three or more groups, then you can use ANOVA. Okay, so that's for parametric tests. Let's talk about non-parametric tests now. Non-parametric tests. Of course, if you know parametric tests, non-parametric tests will just be the opposite of that. So here we can say these tests do not assume any specific distribution. So if you don't know the distribution it follows, probably you have to go for non-parametric test. So this test do not assume any specific distribution for the data. So even if the data is on interval or ratio scale, that's not a guarantee. As far as you don't know the distribution it follows, then you may have to use non-parametric. So non-parametric tests are used when the assumptions for parametric tests, when the assumptions for parametric tests are not met, such as when data are ordinal or nominal. Well, I mean, just like we said already, it is not enough that the data for parametric test, right? It is not enough that the data is interval or ratio on the interval or ratio scale, but if it's an interval or ratio scale, the distribution is known, and then you can estimate the mean and the standard deviation for the population, or you know them at least. Then you use parametric test. If any of those things fail, then you have to come non-parametric. So as when data are ordinal or nominal, like I said, so they are more flexible, right? They are more flexible. Parametric tests are more flexible and can be used for smaller sample sizes. For smaller sample sizes. So smaller sample sizes. Then let's talk about examples. So first, I think I've treated, yeah, this has been treated already for sure. So the Mann-Whitney U-test. Mann-Whitney U-test. Okay. Mann-Whitney U-test. So it compares differences between two independent groups. That is, groups that don't have anything in common. Two independent groups when the data are not normally distributed. Okay. Then we have the Kruskal-Wallis test. Kruskal-Wallis test. Okay. Which is also a non-parametric alternative. It's a non-parametric alternative to ANOVA. ANOVA can take care of three or more groups. Parametric alternative to ANOVA for comparing three or more groups. For comparing three or more groups. Okay, so second part down. Let's see the third part. With the aid of an appropriate diagram, highlight data and its types. Highlight data and its types. So let's talk about that. So that is part C now. C. Talk about data and its types. So first of all, data refers to information collected for analysis. There's this popular one that data is unprocessed information and information is processed data, something like that. The data refers to information collected for analysis, which can be numerical. Data can be numerical or non-numerical, or what you can call categorical. Okay. It can be classified into various types. First, you can have qualitative. You can have qualitative or categorical data. Okay. And for qualitative and categorical data, right? In that case, you can have nominal. So there are two scales that fall here. Nominal, it can be nominal, meaning that data, that's data with categories, data with categories that have no inherent order. When you talk about things like gender, male, female, color, black and white, you can't say black is ahead of white or anything like that. So then we have what we call the ordinal. So under qualitative or categorical data now, you can have the data can be ordinal, nominal or ordinal. So if it is ordinal, here you have data with categories, right? Nominal data are without categories. Oh, the nominal data are with categories rather, but they have no order. But ordinal data are with categories. They have categories, data with categories that can be ordered, e.g., education level, education level rankings, maybe first position, second position, and things like that, and so on. Okay. So data can be qualitative, which is qualitative or categorical, and in that case, it can either be nominal or ordinal. And then in another number two, data can be quantitative, quantity. So qualitative, quality, quantitative, quantity, quantitative, quantitative, which is also known as numerical data, numerical data. So in that case, so when you talk about numerical data, then that can be either discrete, it can be discrete or continuous. So it can be discrete or continuous. So when it is discrete, right, that means takes that is data that takes specific values, e.g., number of students, shoe sizes. I mean, for this kind of question, you have to be, yeah, you have to be careful to follow whatever you're given in class. So somebody else may answer this in another way. So please be careful of your particular situation and follow that. So quantitative data, because we're following the pattern of how it appears on the measurement scale. So here we can be talking about say interval scale and ratio scale. So so it can be continuous, right? Like so if it is continuous, it means we have data that can take any value. It can take any value within a range. It can take any value within a range. In this case, you'll be talking about height, temperature, and so on and so forth. Okay. Now, talking about diagram, right? With everything we've said so far, we can represent this in a diagram. Say, um, and say here is a diagram. There's a diagram highlighting the classification of data. So first of all, you have data, and at the next level, You have it can be you have it to be qualitative. It can be qualitative or quantitative. Then down there, okay, further down, you can have for qualitative that can be nominal or ordinal, like we've shown up there. And then quantitative can actually be discrete or continuous. And if you're following the scale thing, you may now see maybe interval or ratio, something like that. Yep. So with this, we come to the end of this video, having answered all the three questions in this, the three questions involved here. So if you have not subscribed to this channel, be sure to do that. Hit the notification bell also so that you can always get alerted each time a new video is released. Like, also share so that more people can have access to these videos. Till I come your way again, keep crunching the numbers and keep getting things right. All the best all the way. Bye.